Okay, so now that we have an understanding of set building notation, let's look at these two examples and their representation of the number line. So first we have x is an element of the real numbers such that x is greater than or equal to 0. Now we have this greater than or equal, which means that the dot on 0 must be filled in because this is including the 0. The next one, we have x is an element of real numbers such that x is not equal to 0. In this case, we have the dot is open when x is equal to 0 because that's not included. Everything else, however, is included. Now, you may have realized that, well, we just want to express something like this or this, but we have to write all of this, and it can be even longer if we have even more conditions, right? And it becomes really difficult to read as such. Mathematicians, they realized this long ago, so they introduced something called interval notation. Interval notation is where we use brackets and open parentheses to indicate the conditions that we want to communicate. Now, keynote is that interval notation most of the time it assumes that you're in real numbers. So you will not be using this if we're talking about just natural numbers, for instance. Now we have these two notations right here. We have these two. We have the brackets, the open brackets, and we have the square brackets. Now these are also known as parentheses, and what these represent are just greater than or less than or greater than signs. So that means if we have so this is equivalent to something, for instance, like x is greater than 0, we would use the open brackets, the parentheses. However, if we want to include 0, like the first example, we have to do it be equivalent to x is greater than or equal to 0. So that's the difference between these two brackets right here. Now let's try rewriting these two set builders as interval notation. And since we're given a number line, it should be relatively straightforward because we visually get to see what we want to encapsulate. Now so for the first one, we start at 0, right? However, it's included, so we must use the bracket. So we have number 1, we have the bracket 0, comma means what's the next, it's to separate between the first number and the second number. Second number is going to be infinity. Technically, infinity is not a number, but we'll get to that. And close the bracket. Now, notice how much easier that is to write than what we have up there. So I'm going to give you a quick rundown what this means. What this means is every single number, all real numbers between 0 and infinity, these are all the numbers contained in our set. If the number lies in between these two numbers, then that's part of our set right there. Pretty simple, right? So let's try number 2, which is a little bit harder, but after I explain it to you, it should be pretty simple. So we're going to do the exact same thing as we did here, except we're going to start from negative infinity because that's allowed from our set builder notation. Negative infinity all the way to 0. Notice that the 0 is not included, so we have to end it with a parentheses. We have a u here. U means union. What this means is combine these two intervals together to be one set. So basically take this part of the set and combine it with this part of the set. Right? Then we write the next part of the interval, which is 0 to infinity. Which is pretty straightforward, right? This is basically everything. 0 all the way to negative infinity and 0 to positive infinity. Now let's consider why I've used the open parentheses for infinity and negative infinity. Well, first of all, we must realize that infinity is actually a concept. It's not a number. Because when I tell you we have infinite number of things, that doesn't actually mean anything because it's undefined. We don't know what infinity is. Because if we try setting infinity to a number, let's say infinity is equal to, I know that 99 is not a big number, but let's say infinity is equal to 99. Infinity, therefore, by definition means the maximum, which is the biggest number. There's no going past that. However, we know for sure that there's a number called 100, right? It's simply infinity plus 1 in this case. However, that contradicts the idea that infinity is a max. Therefore, infinity is not a number, it's just a constant. And because of that, we must write our interval notation when we encounter infinity with the open brackets. The reason being is because infinity is not a number. We cannot encapsulate a number, and infinity has no max, right? Because it has no max, how can we encapsulate that in our interval? So that's the reason why for infinity we must use the open brackets. So hopefully this was a pretty good rundown and explanation of the interval notation and the rules for infinity. In the next video we'll do more examples converting set builder notation to interval notation.